Thank you, Charlie. Can I have the three speakers go to the front of the room? And as they are, I'll say I think that the three presentations you just heard from Jeff and Glenn and Charlie illustrate how rich of a topic we're dealing with in the workshop today, how much intellectual merit there is to studying this topic matter, and how much work we still have to do to expand the existing knowledge base. There's a lot of research that still needs to be done. I'll kick off the questioning and relate the first question to, I think Jeff referred to interstitial spaces and other unoccupied spaces. I think this is an area that our community has completely dropped the ball on. It's incredibly important, and there's just so little research going on in that area. Glenn also mentioned chemistry in interstitial spaces, and certainly there are a lot of semi-volatile organic compounds in interstitial spaces associated with weatherization barriers and that kind of thing. So given that it, I think, relates to all three of your presentations, can you comment or speculate on the importance of unseen spaces in buildings with respect to the topic matter you discussed, and perhaps each of you choosing a research need related to unseen spaces?
So I'll start with, I mean, I think the spaces are very important, and we know from energy conservation practical work that those spaces are very well connected to the rest of the building. So I would identify as an important research need understanding the concentrations in those spaces of particles, both airborne and deposited, as well as how they change the distribution of particle size and concentration coming from outdoors.
I'd say I don't really know. I mean, we don't know that much about interstitial spaces and the chemistry that takes place in them, and I guess that's the big research question would be to start taking samples. Broadly, I'd say that we have a great deal to learn about the chemistry indoors, and applying some of the instrumentation that we've never used in the main spaces and the interstitial spaces. Just deploying them will learn a great deal. A great deal of discovery will occur.
I'll use a specific example to answer your question, Rich, and I'll focus on chemical composition. As some of you know, I used to work at Bell Labs and the phone company, and the phone companies had data centers, and the data centers would use raised floors sometimes, and air would come from the raised floor into the equipment to cool it. And those raised floors on some occasions contained large amounts of wiring, and that wiring was plasticized. And we did some sampling of PM that was coming into the various pieces of data equipment from underneath the floor. And that PM was grossly enriched in phthalate esters. It was apparent that the phthalate esters that were plasticizing the cable under the floor were influencing the composition of the PM. So I think that's an example of how this really can be an important thing to think about and consider.
Thank you to all three of you, and I'll open up questioning to the committee. Any committee members have questions for Jeff, Glenn, or Charlie? Brent?
Brent Stevens, Illinois Institute of Technology. I had great talks from everyone, and I felt like we've had a full day of lectures in that 60 minutes. Charlie, I have a quick question for you that I just don't know very well. In the framework for dealing with SVOC partitioning, we use TSP. We use total suspended particle mass. What do we know about size resolution of partitioning?
Okay, so we use TSP because it's easy, and these are crude estimates to begin with. I think it is important to appreciate how crude our estimates of our partitioning are, and I think of these estimates as order of magnitude type estimates. You could certainly refine the estimates by looking at the fraction of organic matter in different size ranges and calculating partitioning size range by size range. Okay, you would improve things that way, but given the nature of these estimates, often simply using TSP, I think, is sufficient, recognizing how crude these estimates are.
I think we have a question from an outside participant. Is that right?
That's right. This is a question from Linda Wigginton. She writes, when using Dylos monitors as part of a low-cost monitoring project, we've seen significant spikes from humidifiers and boiling water, sometimes showering. In one case, tap water was used in a humidifier, and when it was switched to distilled water, particle counts were a 20th as much, indicating this was not just a humidity effect, but rather something in the water. Has anyone studied particle emissions from water?
Yes. and what she's referring to is sometimes described as gray dust. And if you use something like an ultrasonic humidifier to suspend tap water, the water you're suspending, those little droplets, contain water-soluble salts, and as the droplets evaporate, you're left with the solids. So indeed, if you're humidifying with something like an ultrasonic unit, it's very important to use deionized water, distilled water. And yes, this is something that a problem many people have encountered.
And this was a related problem in the use of swamp coolers. There was a type of swamp cooler that used to be used in which the water was aerosolized, and this was causing a lot of problems with a high particulate load.
And just to add to Glenn's point, especially HVAC systems often involve the generation of water, either for air washing purposes or for humidification purposes. And so that's another transport route that's been, to my knowledge, largely unexplored.
The next question we have offered from the web is from Greg Sawinski. He notes, my new web-based home Honeywell thermostat is collecting data on temperature and run times. Perhaps this can help with the data gap you spoke of, and he anticipates other devices are doing the same. For Jeff?
Yeah, I think that's a great idea. So all of the wireless Wi-Fi integrated thermostats by many manufacturers, Nest probably being the most well-known, but there are many out there that do that. There are, I think, two issues that we have to think about with that data. One is knowing something about the building from which that data comes from makes it very useful. So having some path to collect that data. And then the second issue we have to resolve, which I think is resolvable, is the privacy issue. And I know that at least some of the thermostat manufacturers require or feel that the data is an important part of the value that they get from the product. So we have to have some way of getting access to that data, but great suggestion.
Continuing with questions from the web, from Stephen Temis. He asks of Charlie, squalene is highly immunoactive to the extent that it's used as an adjuvant in vaccines. To what extent do you think this indoor contaminant might contribute to innate immune system upregulation?
Good luck. Yes, good luck. I'm afraid that is outside my area of expertise. Howard, would you like to make a guess about that?
I mean, I think the facts that the questioner stated are correct, but you know, there may be something to do with route of exposure here. Yeah. That's pretty different, but I don't know.
Yes, and what Howard's referring to, of course, is inhalation of squalene versus, direct injection into the blood, right?
Into the skin.
Into the skin, sorry.
Or dermis.
Any other questions over here?
Yes. You. Yep.
Vito Ilacqua, US EPA. We talk a lot about the epidemiology of outdoor air versus what we have in indoor environments, and the theme of the heterogeneity of buildings has come up in most of the talks actually today. So one of the question that it would be useful to start speculating, where do we start putting our money in? If we were to try and identify the parameters that really are important, as someone actually asked, where would you start? What would be a way to design a program to address this question?
Yeah, that's a really huge question. I mean, it's one that obviously we have to wrestle with. But I think that the idea, the approach, like with many other things, is that there are some real low-hanging fruit. Understanding the amount of surface area, the nature of buffer spaces, HVAC description, and basic operation things are all very cheap, very easy to do. It's much more a question of sampling and actually doing it. And so I think there's one level of things that we should absolutely do because it's cheap and easy. And then I think then we start having to do much more of a cost-benefit analysis, and I think that the combined expertise at this workshop can help identify those things that are really important. And so it might be we need some work with more advanced instrumentation inside to determine what we're seeing, and that points to certain characterization we need to do. So I think we do the easy stuff and then we do the more complicated stuff. But one comment I want to make related to that is there's a lot we can be doing to protect people in buildings that's also cheap and easy. So it's not like we have to wait for the results of building characterization. I mean, it's a no-brainer for certain people in certain indoor environments to be using better filtration or to be using activated carbon filtration, other things. And there's good evidence for that in the literature. And so I think that some of this is an issue that came up, and I know it's going to come up later in the workshop as well, just the communication to the public. There are things we need to know, certainly, but there's also lots that we know that we have to get out there.
I entirely agree. I think that there are some low-hanging fruit. And in this vein, there are some things that we can do now that are probably, if we make the assumption that from the chemistry perspective that SOA indoors is not good. Okay, it's all an assumption right now. We don't know for sure what the direct health effects are. If we make that assumption, it's relatively straightforward to say, okay, well, we know how to remove ozone. Ozone is actually really easy to remove, and that's the main driver of SOA. So again, the low-hanging fruit, I think there's a few things you can do. The things that are much more difficult to do is to change people's behavior. And so integrating into buildings passive or other mechanisms to remove like the main drivers of those things that are important, I think that can be very useful.
At this point, I have nothing to add to what Jeff and Glenn have said. I do think it's worth revisiting this question at the end of the workshop, however.
Okay, so we have a sequence of hands that have gone up. I saw another hand over by Paula. Did you have your hand up previously? Okay, so then I think the next hand was the gentleman behind me.
Actually, Lynn.
Okay, Lynn.
Lynn Hildeman, Stanford University. I want to get back to this thought of the role that higher humidity might play in the indoor environment. When you start talking about the very different composition of organics indoors, it makes me think of concepts like hygroscopic behavior and surface tension. So I was wondering if any of you have given kind of any thoughts to what that might mean for the chemistry of the indoor environment.
There hasn't been a lot of work here. And certainly the effect of moisture on, for example, hydrolysis rates are relatively low unless you have, unless the pH is relatively high. So there are certain cases where the chemistry is going to be influenced by the moisture content, especially as Charlie's pointed out in his presentation. But there has been a little bit of work on the influence of moisture on, for example, the rate of ozone uptake at surfaces and those conversion rates. And there is some effect on certain materials, but it's complicated. It can be in part exclusion, covering sites and making the chemistry not occur. In some cases, it can help enhance the rate of the reactions. But it's a very important area. I mean, I'm sure Barbara could go on for quite a while about the role of moisture.
Yes, Barb, would you care to address it, please?
Yeah, exactly.
So just to add one piece to that, every HVAC system with an operating cooling coil has got saturated air that's in it, and so high humidity is a reality in many buildings much of the time.
So we have time for two more questions, and I'll work with the last two hands that went up. So the gentleman behind me, I'm sorry, I don't know your name.
David with InLogix. We conduct residential investigations here in the DC region. I'm interested in your thoughts on the challenges for sampling and investigation in residences that have a dynamic chemical and particulate environment, especially with homes that have equipped HVAC systems equipped with UV light systems, because we're finding a concerning relationship of these homes with health symptoms and UV lights, and it's amazing how the symptoms disappear when those systems are turned off. And that really, from a health perspective, that's really concerning for given the amount of systems that are related.
Sure. Well, we know that UV lamps can potentially deactivate certain microorganisms, but we also know very well that they can produce a lot of ozone, and that ozone can go on to be a direct irritant in the lungs, or it can go on to generate reaction products like the ones we've talked about. So certainly, I'm not a big fan of anything that releases ozone into the environment like the UV lamps. Do you want to say anything about that?
Yeah, I have nothing to add other than they are becoming quite common, and UV lights also contribute to the degradation of some of the HVAC materials. And as we move towards things like the use of more plastics and more insulating materials in HVAC systems, I expect we're going to see some interesting things with UV degradation of those.
And I would add, I actually see these units a lot in animal shelters and have measured very high ozone concentrations in kennels and animal shelters. So, last question.
Getty Mainellis, Rutgers University. I just have two comments. One is about ozone, and what I thought of is personal care, personal products such as these fancy hair dryers that produce science. Actually, I recently, just for fun, measured one, and it produced about 10 ppbs above background of ozone. So that means within the breathing zone of the user, the ozone levels would be increased, and who knows how that would affect chemistry and exposures. And second comment is about water droplets as sources of indoor PM. Having deionized water or purified water would decrease concentration of particles that come out of the droplets, but would not completely eliminate those. What we have observed, even if you buy the most pure water that is used in molecular research, that one vial costs about $100, if you aerosolize that water and you desiccate it, you still are left with nano-sized particles that would remain as a source of exposure.
What are they?
Residual film residue, we don't know what the composition is, but even, as I said, even if it's the most pure water, we were very surprised. You desiccate them, you still have nanoparticles left.
Well, no, go ahead, Charlie. You're the
I was just going to speculate, Getty. I wonder to what extent when you aerosolize that ultra pure water, you've got very quick equilibration between gases in the air and that ultra pure water. And then when that ultra pure water evaporates, you're left with the sulfate and nitrate residues, something like that.
And if I may, beyond that, you take water, which is a good solvent, and you put it in contact with slightly soluble materials like the reservoir container for your nebulizer. And then you're going to have a residue that has dissolved. It wasn't part of the original water from the container, and that gets sprayed up, and that could be the source of the particles.
To address the ozone point, yes, those hair dryers are probably not a very good thing. And there are a lot of devices that are unregulated that generate ozone. Some are actual ozone generators that can produce unbelievably high amounts of levels of ozone or emission rates. And some are just, they make ozone like the UV devices indirectly, not unintentionally. But there are quite a few devices that people wear around their necks that generate ozone. I had students testing it as usual in my class this year, and I was surprised at the concentration we could get near the face with one of those if it was really close to the face. So, not good.
Okay, so I think this is going to conclude session 2, and I'll reiterate something that Brent Stevens said a few minutes ago, and that's that I think this session is essentially 3 graduate courses in 90 minutes. It's just rich with great information, so I want to thank all 3 of our speakers again. And